pirouette is when a dancer spins on one leg while the other leg is bent with the foot resting near the knee. This position is called passe. It might look simple, but it takes a lot of balance and core strength to stay upright and spin smoothly. Dancers usually prepare by pushing off the floor, keeping their body straight, and using their arms to help control the speed of the turn. An elasticone turn is kind of different. In this turn, the dancer still spins on one leg, but the other leg is stretched out on the side, staying straight the entire time during the turn. This leg position is called elasticone, which means to the second in French, referring to the second position in ballet. These turns often involved multiple spins in a row, and dancers open and close their arms to control the speed, pulling them into the spin faster and opening them to slow down. Keeping the extended leg high and steady while turning takes a lot of strength and control. Both of these turns use a technique called spotting, where dancers keep their eyes focused on one spot to stay balanced and avoid getting dizzy. Even though these moves look smooth and effortless on stage, they're actually very technical and require lots of practice, coordination, and an understanding of how to move the body with control. Whether it's a pirouette or an elasticone turn, dancers are using not just their muscles, but also physics to make their turns clean and powerful.
When dancers do elasticone turns, they're using a lot of science. In order to start the turn, they push off the ground, which gives them the energy to spin. Their legs stretch out to the side, helps them stay steady, and their arms control how fast they turn. If they pull their arms in close, they spin faster, and if they open their arms out, they slow down. This is because of a rule in physics called the conservation of angular momentum, which states that when your body shape changes, your spinning speed can change too. Dancers also use spotting, which means keeping their eyes at one point while they turn to help stay balanced and avoid getting dizzy. Good core strength and posture help them stay upright and in control. These physics ideas are all in types of turns like pirouettes and fouettes. Newton's first law of inertia states that an object in motion stays in motion unless acted upon by another force. This means once the dancer begins turning, they will keep spinning until something slows them down, like friction or air resistance. To start the turn, the dancer uses torque, which is a twisting force created by pushing off the ground and rotating their upper body. This torque gets the body moving around its axis. The friction between the dancer's shoes and the floor is important. It needs to be just right. Without enough friction, they might slip. As they turn, balance and gravity help them stay upright. The body center of mass needs to stay aligned over the foot to avoid falling. Centripetal force, which is the inward force that keeps something moving in a circle, helps the dancer stay on their turning path instead of spinning off to the side. This force comes from the dancer's muscles and the contact with the floor. Finally, dancers use a technique called spotting, where they focus their eyes on one point and whip their head around with each turn. This helps them stay balanced, keep their direction, and avoid dizziness. All these forces work together to create a clean and controlled turn.
Jumping in dance is a movement of a dancer pushing themselves off the floor. Getting height in a jump is important so you have more airtime. There are a lot of muscles involved in jumping, like proper core strength, using your arms, and having pointed toes in the air. To safely do a jump, you must use a plie to push off the ground, but to also land with a plie so you don't hurt your knees. There are lots of energy transferred during a jump from the time you leave the floor into the time you land.
One example of a jump is a grand jeté, which means a big leap that also uses physics. When dancers jump, they push hard off the ground using their leg muscles. This push gives them the power to go both up and forward. In science, this is called vertical and horizontal motion. While they're in the air, gravity is pulling them back down so their body moves in a curved path. Even if their legs are stretched high, the center of their body moves in the same smooth arc. When they land, dancers bend their knees and use the strength to safely absorb the impact. It looks light and graceful, but it takes a lot of power, control, and timing to make the jump look so easy. Another example is Newton's first law of inertia, where a dancer stays still until a force, like pushing off the floor, causes motion. Then, Newton's second law shows that the dancer's acceleration depends on the force they apply and their mass. More force or less mass means a faster, higher jump. When preparing to jump, the dancer bends their knee in a plie, storing potential energy. As they push off, this energy is transformed into kinetic energy, moving them upward. The jump follows a curved path due to the projectile motion. With gravity pulling them back down, the impulse from the plie is what launches the dancer. More impulse means a higher jump. Altogether, physics helps explain how the dancers control their movement, height, and grace through science.